Okay, so here we go. We're going to take a quick look at a trigonometric word problem here, but in 3 dimensions. And so the way the question's been worded here is, let's say you've got this tree or pole or building or whatever, and it's 158 meters tall. And then we've got 2 people, let's say A and D here. And we know that the angle of depression from B, the top of this tower or building or whatever, down to A is going to be 25 degrees. So that's from the horizontal down to that line right there, connecting A and B. Now, because of the rules of geometry, we know that this is also going to be 25 degrees right there. And that helps us out a little bit for later on. We also know, we're given in the problem, that the angle here along the ground, and this might be problematic, so I've made this little image here to kind of give you a sense of this. So what we've got here is this horizontal triangles looking like this, and then right here is going to be our 158 meter tower, and then this is where A is, this is where D is. So the angle here along the horizontal, okay, on the flat triangle right there, this is where my 30 degrees is. So right there, 30 degrees. So that's the information that we're given to start off with. And we're told that between A and D, the distance is 1,500 meters. So now the first question that we're posed with here is, what's the area of this triangle ACD? Okay, well, in order to figure out the area of a triangle, what we need, remember, is 1/2 the base times the height. Okay, so what I'm looking for here is I'm looking for the height. So I'm going to draw an altitude from that peak right there. And so what that is in my little diagram, or my little model here, is going to be this length right here. I'm looking for that. Now, I know the height of the tower right there, and I know this angle right here. Now, what that's going to allow me to do is to figure out this side length here, AC. And the way I'm going to do that is I'm going to use trigonometry. I have my angle right here. This 158 is going to be the opposite side to that angle. And this side right here, this AC, that is the adjacent. So the trig function that I'm going to use here is tangent. The tangent of 25 degrees is going to equal 158, what's opposite, over the adjacent AC. Now, you might be wondering, well, why am I doing that? I'm trying to find the height here of this triangle. Yeah, I am. But the majority of the information that I'm given right now is about this triangle up here. In fact, it's the one that I can do the most work with because I know this side length is 158, I know this angle is 90, and I know this angle is 25. Turns out that is the only triangle in this diagram here, in the model here, where I have 3 bits of information, that's the minimum that I need to be able to do any kind of work. So I have to figure out what I can grab from this triangle and use over here. And this side here is going to be common. It's going to be shared between them. That's going to be that baseline right there. So now I multiply up and I get that AC is going to equal 158 over the tangent of 25 degrees. Now, remember a little rule here. I can take the numerator on this side of the equal sign and replace it with switch positions here with the denominator on the other side. Okay? I'm allowed to do that. And I get this right here. And so now I'll pull up my calculator just to get a sense of what that value is. So 158 divided by the tangent of 25. Okay, and I'm going to get roughly 338.8. Now I'm going to leave that in my calculator so that I don't make rounding errors later on. I'm going to leave that whole decimal there. So there we go. That means this distance right here, AC, is 338.8 meters. Now, I can look at the flat triangle. Okay, I can look at the triangle at the bottom here. I know what this distance is now, and I know this is going to be a 90-degree triangle. So now I can use some trigonometry to figure out what h is. So I'm looking for the opposite, and in this case, I have the hypotenuse. So this is a sine function. So the sine of 30 degrees, because that's the angle that I'm given, is going to be equal to h over my 338.8. Okay? And again, in a sense here, I'm going to cross multiply. 1 times h is going to equal sine times 338 here. In essence, I did cross multiplying over here. It's just that I already know that after I cross-multiplied over here, I was going to have to divide. I was going to multiply the AC by the tangent of 25, and then I knew I was going to have to divide by the tangent of 25. So it's just as easy just to flop those two. But over here I wouldn't. I'm just going to multiply 338.8 by the sine of 30 degrees. Okay, so now pull out my calculator. There's my sine of 38. Whoops, there's my sine of there's my 338.8. I'm going to multiply that by the sine of 30. And I'm going to get that the height is 169.4 meters, approximately. Okay? Now, that's what I needed. That's what I needed. So now, the area, okay, of this triangle down here, this triangle ACD, triangle ACD, is going to equal 1/2 the base, which is 1,500 meters, multiplied by the height, which we just determined to be 169.4 meters. So now, I'm going to take and multiply 0.5, there's my 1/2, times 1,500, times that answer there, 169.4, and there we go. So the area, and I'm going to move this over here, the area is 127,062.0 meters squared. So 127,062 meters squared. Awesome. All right, now that was the first question that we were given here. The second question was about the angle of elevation from D to B. So standing here at D, in other words, if you're at this position right here, what angle do I have to look up to see the top of the tower? What is this angle right here? Okay, well this question is a little bit more of a thinker, okay? Because of the information that we're given, it's not immediately obvious as to what we got to do. But what we got to do is we got to find our way to get over here to this side of the triangle. So what we did is we broke that bottom triangle up into two by dropping the altitude. I have some information about this one. Now I got to move over to this triangle right here. Okay, so here we go. So let's label this point right here. I don't know what we got here. A, B, C, D. Let's call this point E. So what I'm going to do here is I'm going to figure out what AE is. And the reason I want to do that is because as soon as I know what AE is, I'll know what ED is. Because altogether, that's got to be 1,500. So take a look at this triangle right here. I'm looking for the adjacent side to the angle 30. And I know what AC is. I've already got that. AC was 338.8. So my cosine of 30 degrees is going to equal my AE, what I'm looking for here, over AC, which was 338.8. Now, I can think of this as cross-multiplying. Oops, sorry. Buckled there a little bit. I can think of this as cross-multiplying, really. 1 times AE is going to be AE. And this will be 338.8 times the cosine of 30 degrees. Now, nice thing about the calculator that I've got here is I'm going to come down. I'm going to multiply. I'm going to just go up with my arrow keys here. I'm going to go up to that number. And I'm just going to grab it. If I press enter on it, it just grabs it right there. So I don't have to retype it. And I can multiply by the cosine of 30. Okay, so my answer here is going to be this approximately 293.4 meters. That's this distance right here, which means ED is going to be 1,500 minus 293.4. So I will type in 1,500 minus that answer. Okay, and so now I've got approximately 1,206.6 meters right here. ED is approximately 1,206.6 meters. Okay, good. Now, how does that help me? Well, remember that what I'm looking for is this angle right here. I've got the side opposite it. If only I had the adjacent side, I could use an inverse tangent. But I don't have that yet. But I do have this triangle down here, and now I've got this base side, and I've got the height. Well, I can just use the Pythagorean Theorem now to get the hypotenuse, the CD. CD squared is going to equal the height squared plus ED squared. And the beautiful thing is I've already got the height and I've got ED. Okay, my height was 169.4. Okay, I had that up here. And then ED I just figured out was 1206.6. Now, when I go to my calculator, I'm actually going to go up and I'm going to grab that one and square it. Plus, and then I'm going to go back up and again, so I'm trying not to round here until the very end. I'm going to let the calculator put as many decimal places in there as I can. And I'll round at the very end here. So I'm going to square those two, add them together. And I get this crazy big number. So CD is going to equal 1484495.587, blah, blah, blah. It goes on for a little bit. So CD is going to be the square root of that. Okay, so go back to my calculator. Square root of that answer, 1218.39, okay? So 1218.4 meters. And now I'm basically at the end because now I know that this is 1218.4. I know that the side opposite the angle I'm looking for is 158. So now I know that the tangent of angle, and the way I've got it set up here is BDC. The tangent of angle BDC is going to equal 158 over 1,218.4. So that angle BDC is going to equal the inverse tangent of 158 over 1218.4. And I'm going to go to my calculator. Inverse tangent of 158 divided by, and I'm going to go up and grab that number so that I reduce any kind of rounding error there. Press enter, and I'm getting approximately, let's say, 7.4 degrees. And that's the angle of elevation that we're looking for. Oops, sorry about that, in this specific problem. Okay, there you go. Hope that makes sense. It's a good question because some of the material that you're given here, some of the information that you're given isn't the information that you need to get to those answers directly. There's a nice little path you got to follow to get the answers here.